Hello everyone, welcome to Grade Up. My name is BYJU'S and we are studying compiler design in these videos. Up till this point, we studied top-down parser, right? We started top-down parser and I said two things are there, recursive descent and LL1. We completed recursive descent. Now we move on to LL1 parsing. For studying LL1, we need to know two functions first and follow. Okay, so now we know we have studied in our previous video. Now we'll move on to the LL1 parsing. Okay, so let us start. As I said, LL1 parsing will contain parsing table, which will tell us that which production we have to choose to produce our string. Now how to generate LL1 parsing table, that is our motive. So see, constructing LL1 parsing table. Let us start now. See, for each production A goes to alpha, if I have some production like A goes to alpha, then I have to do these two steps. See, first step, add A goes to alpha under MAB. What is M? M is the name of table. Under MAB, for all B belongs to first of alpha, right? So see here, what is the meaning of this statement? This is not very complex. See, I have A goes to alpha. This is my production. I'll find first of alpha. Suppose first of alpha is B1 and B2. Suppose. Now you know how to find first. Suppose the first of alpha is B1 and B2. So add this production into the table in entries B1 and B2. Got it? I'll tell you how to do this. Just know the basics. But second point, see, if first of alpha contain null, if it contain null also, then add A goes to alpha under MAC for all C belongings to follow of A. Now if null comes, then you have to find follow of A. Suppose follow of A is C1 and C2. Then you add this production under C1 and C2. Got it? 2 points. Two things are there. A goes to alpha is your production. First find or begin with finding first of alpha. Find first of alpha. Okay. If it doesn't contain null, then insert that production into that B1 and B2. But if it contain null, then find follow of A and insert in that thing. Okay. See an example to understand better. Construct LL1 parsing table for the following grammar. This is your grammar and this is your parsing table. And what is this parsing table? See, these are your variables S, L, L dash, and these are your terminals A, comma. See, comma is also terminal. Opening bracket, closing bracket, and dollar. Always keep dollar in your table. It has some relevance, I'll tell you. Okay. Now you have to fill this table. So there are 1, 2, 3, 4, 5 productions. First production is S goes to L. Now, this is something S goes to L, opening bracket, L, closing bracket. Now, find first of this. First of opening bracket, L, closing bracket. What is first? Opening bracket. The first of this is opening bracket. So, place, there is no null. First point is valid. So, place S goes to L here. Now this is over. Now second production is S goes to A. What is the first of RHS? What is the first of right hand side? Small a. So place S goes to A here. I am placing in S only. The production is S. That's I am placing in the first row. Now these two are over. Now go to second. L goes to SL dash. What is first of SL dash? It is first of S. What is first of S? It is opening bracket and A. So place in both the things. L goes to SL dash also comes in A. L goes to SL dash also comes in opening bracket. As I said, place everywhere. If two things are first, place in both the things. Got it? Now finally, last thing. L dash goes to null. What is first of null is null. So you cannot take directly. You cannot place anywhere. There is nothing null. Right? So, find follow of L dash. What is follow of L dash? See, where is L dash? Here it is. Follow of L dash will be follow of L. Now, what is follow of L? See, follow of L is closing bracket. So, place L dash goes to null in this entry, right? Finally, L dash goes to comma SL dash. What is the first of this thing? Comma. So, L dash goes to comma SL dash. So, this is your LL1 parsing table. This is how you generated LL1 parsing table. Only two things to keep in mind. Begin with finding the first of RHS. If it doesn't contain null, no problem, place the productions. If it contains null, then find the follow of LHS. Got it? So, this is your final LL1 parsing table. Now, how to use this parsing table? How to use this parsing table to generate your string? See, accepting string with LL1 parsing table. This is your final table. This is the table we generated in our previous step. Okay? This is the table we generated. Now I'll see how to generate our string. Suppose our string is this. Opening bracket A, closing bracket. We want to generate this string. Now we'll see how to generate this string using our parsing table. See, the first thing is opening bracket. And currently we are at symbol S. And the first thing is opening bracket. Now see, you are at S and opening bracket comes. What will you do? Which production you will take? S goes to L. Right? This is the way. You are at currently S, and if an opening bracket comes, which production you will take? S goes to L. Got it? Any problem in this? Now you are at A. Now you are at symbol A and currently you are at L. Now do the same. If you got A on L, what is the production? L goes to SL dash. Got it? Any doubt up till here? Now, you are still at A. Why? Because you are in this production. Between these two brackets between these two brackets, you are at A only. You are at production A only. So, if A comes on S, what will you do? S goes to A. Cleared? Now, next thing. Now this thing is over. What is remaining? L dash. And what is coming? Closing bracket. So if L dash closing bracket comes, what will you take? Null. Got it? See, you just go via a single path. At any step, did you backtrack? Yes, this is wrong, I have to backtrack. Did you do anything like this? No. So that's how you use this LL1 parsing table. Got it? There is no choice at all. You will always select the right production. You are selecting the production in the order which will produce your string. Clear? Now this bracket is also over. Your string is accepted. And this is the final parse tree. Cleared? Any problem that how you generated LL1 parser table and then how you accepted your string? Cleared? Any problem in this? Good. Now, see for one more example. Now try it yourself. Now. Generate LL1 parsing table for the grammar. Grammar is given to you. You have to complete this table, right? See, first thing. First production is S goes to ASBS. What is the first of this? A. So, S goes to ASBS comes into this. Now, another production S goes to BSAS. What is the first of this? B. Place it here. Very simple now. Last thing, S goes to null. But what is the first of this? Null. You cannot take null. So where will you place? Follow of S. Now S is here also, here also. What is the follow of S? B. Comma. What is the follow of S? A. And S is also starting symbol, so dollar will also be a follow and nothing else. So place this production in A, B and dollar. So S goes to null comes here, S goes to null comes here, S goes to null comes here. This is the final parsing table. Now see what is the problem. In a single entry, there are multiple productions. In a single entry, there are multiple productions. See here also. Here also. In a single entry, there are multiple productions. Suppose while parsing your string, you come at this point, S and A. Which production you will take now? Previously only one production you will take. Now at this point, which production you will take? That is a confusion. So see here, as multiple productions are there in single entry, hence the grammar is not LL1. It is always not necessary that your grammar is LL1. This grammar is not LL1. Why? Because there are multiple entries in your parsing table. Cleared? Any problem? Good. Now our next question, checking whether a grammar LL1 or not. Checking whether a given grammar is LL1 or not. Now there are two methods for this. There are two methods. First method, draw the parsing table. Draw the parsing table and check if somewhere multiple productions come, it will not be LL1. But that is a very long method. If very large grammar is given to you, the parsing table is also very large. That will take so much time. So the next method is disjointness. The next method is disjointness. What is the method of disjointness? See, there are two cases to check. First, if the grammar doesn't contain null production, if grammar contain null production. There are two cases. If your grammar does not contain null production, and other one, your grammar contain null production. So see, this is your grammar. S goes to alpha 1, alpha 2, alpha 3. Null production is not there. Now, for the grammar to be LL1, these three conditions must be true. What are these three conditions? First of alpha 1, first of alpha 2. You will find. If you find your intersection, it must be phi. First of alpha 2 intersection first of alpha 3 must be phi. First of alpha 1 must be first of alpha 3 must also be phi. That means they must be pairwise disjoint. Disjoint means their intersection must be phi. Pairwise, if alpha 4 also, you will take that also into account. If alpha 5, you will take that also. Make pairs, make all possible pairs and then decide disjointness. Got it? Right? Now, second case, if your grammar contain null, see, grammar contain null, then you have to take first of alpha 2 must be phi, right? First of alpha 1 with follow of f. You know, if null is there, if you find its follow or first, if you find its follow, it will go to S. That's why first of alpha 1 with follow of S. First of alpha 2 with follow of S. Again I say, pairwise disjoint. So if these condition is true, if these conditions stands true, then your grammar is LL1. So disjointness is a very fast method to check a grammar is LL1 or not. Clear? Now see an example to check, see an example to study. See, first grammar, S goes to EA, E goes to A. Right? You have to check whether it is LL1 or not. Do you need to check for this grammar, for this production? Do you need to check? I said S goes to alpha 1, alpha 2, alpha 3. This is valid where you have choices. Where you have choices at RHS. Is there any choice? Don't check for this. Don't check for this. Check for S. So S goes to E and A. So you have to check first of E intersection first of A. Whether it is phi or not. So what is the first of E? First of E is A. First of E is A. Intersection first of A is A. A intersection A is A. It is not equal to phi. Hence, your given grammar is not LL1. Your given grammar is not LL1. Cleared how I did it? Any problem in this? Now come on to second grammar. First production. Do you need to check for first production? Is there any choice? No. So it is correct. It has no issues. Now check for this. It has null. That's why you have to do like this. First of A. This first of A intersection with follow of A. Okay. Check first of A is A. Intersection. What is follow of A? See, S goes to A, B, B. What is follow of A is first of B. What is first of B? D and null. But you cannot take null in your follow. So remove this B also. What is the remaining? B. So follow of A is D and B. What is the intersection of A, D and B? What is the intersection of A, D and B? It is phi. Nothing is common. So yes, this production is also correct. Check for this production yourself now. B goes to D and null. So null is there. So first of B intersection follow of B. What is first of D? D. Intersection follow of B. See here, S goes to A, B, B. What is follow of B? First of B. So D intersection B is also phi. So this is also correct. Hence, this is a valid LL1 grammar. Got it? This is a way to check. See, there is no need to make that much large parsing table to check. You can do using disjoint method. Got it? Any problem in this thing? Good. Now, do the same for now these things now. Two more examples now. Please try it yourself. See, S goes to AS and A. Only one production is there. Okay. No null. So, first of AS intersection first of A. What is the first of AS? A. Intersection A. A intersection A is A, which is not phi. Hence, it is not LL1. Very fast. You have to do very fast now. Please do it for this now. Again, it doesn't contain null. So, first of SA intersection first of B. Right? What is first of SA? It is first of S. Intersection first of B is B. What is first of S? It is B. B intersection B is again B, which is not phi. Hence, it is again not LL1. It is again not LL1. Now see the main conclusion. Here it is. See, this grammar is left factored or not? This grammar is left factored or not? See, left factoring, both side A. This grammar is left recursive or not? This grammar is left recursive or not? So, if your grammar is either left factored or left recursive, it cannot be LL1. Same thing I have written. If any grammar contains left factoring of left recursion, it cannot be LL1. So, directly don't need to check anything. If your grammar contains left recursion, directly you can say it is not LL1. If your grammar contains left recursion, directly you can say it is not LL1. Got it? Any problem now? LL1 is over. Any doubt in this? Good. So as I said, that's all for your LL1 parsing, right? We completed one type of parser, that is top-down parser. Top-down parser has two types, recursive descent, non-recursive descent. We completed recursive descent, now we completed non-recursive descent, which is also called LL1. Okay, so now go and practice some previous year questions on LL1 parsing. I'll discuss previous year at a time at the last of all the parsing techniques, okay? But you yourself practice right now. So if you have any doubt, you can ask, okay? So now we'll start with our next parsing technique, that is bottom-up parsers. That is a pretty good topic, okay? We'll study in our next video, okay guys? So stay updated. Thank you so much.